In the previous lesson, I introduced you to DRF view sets. In this lesson, I'm going to show you the built-in web interface and explain how renderers work. Built into the DRF is a web interface. The same URLs I've been showing you in previous lessons. If you hit those with a web browser instead of something like curl, you'll get a full HTML page, including the payload and the ability to run actions on the objects. How does DRF know what to respond with? Well, there's two answers to that question. First, what renderers are installed? And second, what HTTP accept headers are sent? For example, if you had a YAML and an HTML renderer installed, and your program sent the following accept header, accepting JSON, indented JSON, YAML, HTML, and everything else, then YAML would be used because it's the first renderer that matches that accept string. Up until now, when I've been using curl in the demonstration, curl by default accepts star.star, so it hits the first renderer installed, which by default is the JSON renderer. You can affect what renderers are used by changing a setting in settings.py. Declare the REST framework dictionary with a default renderer classes attribute, and that specifies what renderers to use. What's showing here is actually the default. If you don't specify anything in settings.py, this will be what you get. This says to use the JSON renderer and then the web API renderer. As I mentioned, curl accepts everything, and because JSON renderer is declared first, this will be what matches. In a production system, you may not want to use these default renderers. As an example, the web renderer will download all sorts of options for choice fields. So if you have a field with thousands of possible choices available to it, the browser will download this every single time. By making the web renderer available, you are potentially opening yourself up to a denial of service attack. It's very handy to have this renderer when you're debugging, but it's not a bad idea to turn it off once you go into production. The web renderer also makes your API far more discoverable. A lot of information is presented. Now, all of that information is still queryable through other renderers, but it makes it easier to find. Security through obscurity isn't a valid approach, but why make it easy on people? In addition to setting the renderer inside of settings.py at a global level, you can also set it specifically. For example, in a view class, you can use the renderer classes decorator to specify what renderers are valid with a view. This one only supports the JSON renderer. Notice that the parameter to the decorator is a list, so you can specify multiple renderers if you wish. Alternatively, you can also set it inside of a view set. View sets inherit from API view class, and all API view classes support an attribute called renderer classes. This is similar to using the decorator in the previous example, but it sets the renderer for all of the actions associated with this view set. The DRF comes with a bunch of different choices for renderers. You've seen the JSON renderer already. The template HTML renderer uses Django's template engine to render whatever template you pass it. The static HTML renderer takes a string, which is supposed to contain HTML. You still use the DRF response object, but in this case you pass it the string that you want rendered. The browsable API renderer is the web renderer, which I've been talking about and will show you shortly. The admin renderer is similar to the browsable API renderer, but the interface looks like the Django admin instead of the default. The HTML form renderer renders a HTML form object. Typically, this isn't used on its own, but used in conjunction with a template, which is then fetching a form. The forms are then based on the body of the REST elements. The multi-part renderer is another one that isn't used on its own. This is also for forms, but in this case multi-part forms, and typically is only used for testing. In addition to all of those, there are a whole bunch of third-party packages as well, supporting YAML, XML. If you're not happy with the format of the JSON, there's multiple different types of JSON, so you can make it look just about however you like. Message pack, Excel, CSV files, a variety of Panda-based plugins which support CSV, Excel, and PNG, and LaTeX, of all things. The DRF renderer system has been built so that you can customize it and create your own. If you want to look into this, you can look at the API guide in the renderers section. And now let me demo the web interface. In a window off screen, I'm running the Django dev server. I'm going to hit the same artifacts URL that I showed you with curl in the previous lesson. And here's the web interface. The API root view is whatever you defined inside of the default router. At the moment, all I have defined is the artifacts section. Down here in the body of the response, you see the headers that came back, as well as the payload. This is just like the curl view before, but has the added benefit of the link is now clickable. Clicking the link gives me the retrieve method, the list of artifacts, in this case showing the 2 artifacts that are in the database. If I scroll down, there's a form that complies with the artifact serializer. Clicking Post will call the create method in REST. The end result on the screen is the newly created object, with ID3, name, golden idle, and shiny set to true. In the breadcrumbs at the top, I can go back to the artifact list, and now you'll notice I've got 3 objects in the database. I can modify the URL of the top and specify a particular ID doing a retrieve. And here you are back at the detail information for artifact 3. Notice this allow header tells you just what HTTP methods are available for this particular object. Because the artifact view set was default, it supports all of the possible HTTP methods. Scrolling down once again, I can change the form, click on Put, and this will cause an update to happen. Just like before, I've changed the artifact from shiny to not so shiny. Along the top, there's a delete button so that I can call the delete method. It confirms, which I approve, and it tells me that the object has been deleted. Notice that the URL is still for object number 3, but there's no information here because there's no content for object number 3. Clicking back on the artifact list, I'm back to having just the 2 objects. If you're tired of the web interface and want to see exactly what comes back, you can change the format of the GET using this button on the right-hand side. By selecting JSON, the page now comes back as JSON. This particular view is what Firefox does with JSON. Clicking on raw data shows you what actually came back. As you can see, this is a really powerful and useful tool. I use it almost continually whenever I'm trying to debug my REST APIs. That's it for the web interface. Next up, I'll show you how to control access using DRF permissions. In the previous lesson, I showed you the DRF web interface and renderers. In this and the next lesson, I'm going to be talking about the DRF permissions. The Django REST framework has a robust permission mechanism. The most common usage of it is tied to your view sets. You can specify permissions at both the request level and at the object level. An example of request would be whether or not you're logged in. An example of the object is whether or not you are able to look at or change that particular object. In order to demonstrate DRF permissions, I'm going to have to set up a whole bunch of Django auth pieces. I'm going to spend this lesson prepping and the next lesson diving into the actual DRF permissions. If you are very comfortable with Django auth, logins, creating login screens, and creating accounts, you can skip this lesson and not worry about it. If the Django contrib auth module is new to you, then you might want to stick around. Everything that I show you inside of this lesson is moving towards the fact that I need a couple more accounts than just the admin account. I'm going to create an account called Indy that has the staff setting set to true, and another account called Marion that's just general usage. Out of the box, Django no longer comes with a login page. In order to be able to play with this and have accounts log in and log out, I'm going to need to create a login page to go with these accounts. This lesson is going to be just a short review on how these pieces work. If you want to see details on how to use the Django auth library, this article could be of use to you. The first change I want to make isn't really necessary, but it will make your life a little easier. Inside of Fedora settings, you'll find a definition for auth password validators. This specifies what password validators Django runs when you create an account. Because I'm just going to be messing around and I don't want to have to deal with this, I'm going to zero all of this out. This is generally a bad idea. You're breaking built-in security. But, it's just between us friends, so I'm getting rid of that. The second thing I need to do is create a login page. That's going to be rendered as a Django template. In order to do that, I'm going to need a templates directory. So I'm going to make that inside of the Fedora project. The template itself has to go in a directory called registration. So inside of the templates directory, I'm going to create another directory called registration. Once those directories exist, I'm back into Fedora settings, and I need to tell Django to look in those directories for some template content. Look for the templates definition and change the value for the DIRS key. It needs to be changed to point to that template directory. Base dir is defined near the top of the settings file and specifies where the project exists, so templates is relative to that base dir. If you happen to be using an older version of Django, do note that Django 3 uses the path module. This base dir is defined as a path. In Django 2 and before, this would have been an os.path.join call. While I've got settings open, I also want to make one more change. I'm going to tell Django where to go if someone logs in and they aren't explicitly told to go somewhere. So this is the default definition for a logged in user. I'm going to set that to a view called library. Django provides views for doing authentication, but does not include them by default. So I'm updating the Fedora URLs file to include the URLs for those views. They're in the contrib auth module, and I'm going to include them under a path called accounts. Finally, I need the actual template for the login page. I'm going to create the world's simplest login HTML. It's not very pretty, it really just has the form in it, but this will do the job. This HTML code goes inside of a file called login.html inside of that newly created templates/registration directory. The contrib auth module automatically looks for a template with this name, and that's how these pieces are wired together. With all that set up, I'm now ready to use the Django admin to create a couple of accounts. In a window off screen, I'm running the Django development server, and now I'm going to point the browser at localhost/admin. Once again, logging in with my super secret password. And now in order to create two accounts, I'm going to click on the add button for the users. The first account I'm going to create is for Indy. I type in the username and passwords, being grateful that I turned off the validators. And when I hit save, the admin will let me edit this newly created account. Indy was added successfully. I'm going to scroll down to permissions, make Indy staff, and save. And you can see that Indy has been added. Adding one more user. Because I don't need to make any more changes for Marion, I can just scroll down to the bottom and save. As you can see here in the listing, Indy is staff and Marion is not. Great, now that you've got those accounts, you're all set to see how the DRF and permissions actually work, coming up in the next lesson.